The first section we're going to talk about today is section 8.7 on solving nonlinear equations. This is very similar to what we've already been doing, but we're not going to be using matrices in this section. We're just going to be using the same three basic techniques that we used in 8.1. So our basic techniques involve graphing, since we're super well versed in graphing, substitution, and elimination. These are our tools and our toolkits. Oops, I can't spell. Elimination. And we're just going to dive right into some examples here. Example number 1. Solve the nonlinear system. And we'll start off with something pretty easy here at first. Let's see. X squared plus y squared is equal to 16. And 9x squared minus 16y squared is equal to 144. So let's talk about this. First of all, these are obviously nonlinear. That is to say, these aren't lines. This is a circle, and this is a hyperbola. And hopefully you guys are well versed enough in those graphs of those curves that you can sort of tell just by looking at these equations what we have here. And one of the first things that we should probably do in all of these cases that's really important is to graph each one of these. So step 1, graph the curves. Now, we're not actually going to use the graph to solve this system. We could if it worked out fairly well, but there's a couple of reasons why we want to graph these curves. Why? These are some big ideas. 1, the system may have more than one solution. Now, unlike the linear systems that we looked at, where anytime we had more than one solution, we automatically had infinitely many solutions, that's not the case here. We could have 2, 3, it just depends upon how many points do the curves intersect at. Now, for lines, that was either they're parallel, they don't intersect. They intersect one time if they have different slopes, or they intersect an infinite number of times if they're parallel and they lie right on top of each other. But now we're talking about things like maybe a line and a parabola, which could intersect in 2 locations, or 1 location, or not at all. Or we might have a circle together with a parabola that could intersect multiple times. So it's a good idea for you to graph these first just to get a feel for exactly how many solutions there are. The second reason we want to graph it is not only do we want to know how many we're looking for, if we find more solutions algebraically, that is to say, by working the arithmetic, then the graph shows, that is to say, for example, let's say I do some arithmetic here, and I know that there's supposed to be 4. But maybe we find 6 solutions. This implies that 2 of these solutions are what are called extraneous, false solutions. Now, you might be asking yourself, when are we going to get false solutions? Well, if you end up manipulating the equation in such a way that you change its form, like it was a square root equation, and then you end up squaring both sides and turning it into something that's quadratic that wasn't necessarily quadratic before, you could be changing the form, in which case you change the number of solutions. So there are some techniques we may be using in some of these problems where we get answers that aren't really answers. And what you got to do is, at this point, if we find more solutions algebraically than the graph shows, then graphically, I should say, graphically, we need to check all solutions for extraneous answers and throw those out. Find the two false ones in the case above. So those are two good reasons why we want to be graphing these things before we start. So let's take a look at this particular problem. Let's graph these guys. Our equation 1 here. Oops. Our equation number 1 here is x squared plus y squared is equal to 4. So I'm going to actually just duplicate this really quick and bring it down. If we rewrite this, this is x squared plus, well, let me rewrite it even more. This is x minus 0 squared plus y minus 0 squared is equal to 4 squared. So this is a circle with center 0, 0, and radius 4. Down below, if we divide both sides by 144, we get x squared over 16 minus y squared over 9 is equal to 1, or x squared over 4 squared minus y squared over 3 squared is equal to 1, and this is hyperbola, with center also at the origin. And the a value here is 4 and the b value is 3, which should be enough information for us to graph it. Also, we might note that this opens horizontally. So it's a horizontal hyperbola. So let's graph these really quick. Let's get our axis going here. And let's get our circle on the board here. I'll do that one in blue. Radius of 4. Something like that. Let's see here. 1, 2, 3, 4. A little bit more. There we go. Perfect. And there's our center. So this is out at 1, 2, 3, 4. As far as our hyperbola is concerned, it goes out from the center 4 in the x direction, in both directions. It goes up 3 in the y direction. And that's enough for us to draw our bounding curve, or our box, excuse me, our construction box. So a little bit of review on graphing hyperbolas. We then get our asymptotes through the center. Maybe the nice thing about these problems is I don't have to mess with anything like the focus or anything like that. I just really want to graph it quickly. And then this one opens horizontally. So let's see, I'll do that in purple. It has a vertex there, and it has a vertex there. And it opens horizontally and starts to hug those asymptotes. Something like that. And so it would appear that the only points that the purple curve and the blue curve intersect are at the points -4, 0, and 4, 0. So this is vertex and vertex. So this can be solved graphically. It appears the only points in common are plus or minus 4, 0. But you shouldn't ever rely on the graph for solving these, because your graph could be wrong, or your scale could be off a little bit, especially if you're drawing this by hand. So, oops, this needs to be adjusted just a little bit. There we go. Algebraically, how do we solve this? So let's look at this again. Solving algebraically. We're going to go through this by the numbers here. I do expect, so we expect two solutions. So let's find them. So our equations are x squared plus y squared is equal to 16, and 9x squared minus 16y squared is equal to 144. So I think what we're going to do is just some simple elimination. We're going to do, if this is equation number 1 and this is equation number 2, I think what we'll do here is something like 16 times equation number 1 plus equation number 2. And that will give us the following. See in red here, we'll have 16x squared plus 16y squared is equal to 256. That was 16 times equation 1. Equation 2 is just 9x squared minus 16y squared is equal to 144. And as we add those two together, hopefully we'll eliminate one of our variables here. This will be 25x squared plus 0y squared is equal to 400. So we have eliminated, eliminated y altogether from this equation, and we have 25x squared equals 400. So as we solve that, we get x squared is equal to 16, or x is equal to plus or minus 4. Oops, I guess I should say this is step 2 over here. Step 2, solve it algebraically. Here we used elimination. So we have possibilities. Possibilities for one variable, i.e. x equals plus or minus 4. At this point, you want to break this up into cases to keep things straight. Case number 1, if x equals positive 4, then we can use substitution to find y. So I'll go back up here and I'll choose either one of these equations. I'll just use equation 1. Using equation 1 that says x squared plus y squared is equal to 16, and x is equal to 4, what we're going to get is 4 squared plus y squared is equal to 16, or 16 plus y squared is equal to 16, which implies y squared is equal to 0, which implies y equals 0. So if x equals 4, y equals 0, and we get the solution 4 is 0 as one of our possible answers. The other case, case 2, is if x equals negative 4. And so then using equation 1 again, x squared plus y squared is equal to 16. This time we get negative 4 squared plus y squared is equal to 16, but that actually gives us the same result. 16 plus y squared is equal to 16. Y squared is equal to 0, in which case y equals 0. And so if x equals negative 4, y also equals 0, and that gives us the ordered pair, negative 4, 0. And that is congruent with what we saw up above. for our visual solutions. Plus or minus 4, 0. And we've solved the system